All right, we made it to the very last section of Chapter 6. Section 6 says Nonlinear Systems of Equations and Applications. Okay, this section I think is going to be short, and it's going to rely heavily on earlier topics that you and I studied, like the Elimination Method and the Substitution Method. Check out this first equation, the first system. All right, look at this. Solve this system. When you solve a system, you're looking at a point of intersection. Now, the reason why they entitled this section Nonlinear Systems is because both of the equations are not linear. The second one is linear. This is a line. It's a linear equation. But this guy is not linear. I mean, you can see the x and the y being squared. What is this, by the way? This is the standard form for a circle, ellipse, hyperbola, or parabola. Which one? If you said circle, you're correct. So this is a circle and this is a line. And they want to know, does the line and the circle intersect? And if they do, where? Now there's a few options. When you have a line and a circle, you can have no solution, right? I did not write the number 10 right here. This is my line. Here, let me do a better job. Here's my line, and there's my circle. If they don't touch each other at all, that's no solution. Another example is the line can meet your circle at just one point. That's when you're just tangent. That's just one solution. Another case could be your line intersects your circle in 2 points. So I just showed you right now, graphically speaking, what your three different options are. No solution, one solution, and two solutions. So we'll figure it out when we solve this problem right now, which case we're in. Either we're going to have no solution at all, or only one point of intersection, or two. All right, let's do it. What I want you to do is look at this system here, and I want you to think about what method you're going to use. I suggest that you use the substitution method. You know, this x variable is being squared, this one's not. This y variable is being squared, this one's not. So the elimination method is not going to work for us. Instead, let's use the substitution method. The substitution method says solve one of the equations for one of the variables. Because these variables are not being squared, they would be sort of easier to solve for. So let's either solve for x or for y. I'll go ahead and solve for x in the second equation. What I like to do many times is label my equations, okay? I'm going to call this equation number 1 and then this equation number 2. So what I'm going to do is I'm going to solve equation number 2 for x, all right? Which simply means I'm just going to add y to the right-hand side. Okay, I'm going to highlight this because I'm going to come back to it later on. Now go to equation 1, which says x squared plus y squared is equal to 25, and make a substitution. Replace x with y plus 1. After all, you're saying x is the same thing as y plus 1. So then when I make my substitution, I'll have y plus 1 squared plus y squared is equal to 25. Do you see my substitution? I replace this x with y plus 1. Now I'm going to have to expand this. Now be careful to expand this correctly. Do not simply square y and square 1. You have to rewrite this as y plus 1 times y plus 1. Okay, so it's y plus 1 times y plus 1 plus y squared is equal to 25. So then this becomes y squared plus 2y plus 1 plus y squared is equal to 25. I did skip one little step, and that is when you do y times 1, that's 1y. When you do 1 times 1, that's another y, so that makes 2y altogether. Now we have 2y squared plus 2y. What I'm going to do is I'm going to subtract 25 from both sides. So when I subtract 25 from 1, I get negative 24 is equal to 0. Whenever I have just one variable in an equation and it's being squared, most of the time I set it equal to 0. The next thing I'm going to do is maybe divide everybody by 2. And that'll leave me with 1y squared plus y minus 12 is 0. I like to factor, so I'm going to solve by factoring, but you can also use the quadratic formula if you like. So I'm going to get y is equal to negative 4 or y is equal to 3. So I need you to pay close attention here. You have 2 options for y. You got 2 options for y. So that tells me right away that the line and the circle are intersecting each other twice. Okay? Now, do you remember earlier, I'm going to scroll down a little bit. Do you remember earlier I said I'm going to highlight this statement and come back to it later? I'm ready to come back to it now, all right? So here we go. Let me section this off, okay? So x is equal to, now one of the values that I'm going to plug in for y, I found it to be negative 4. So here I go. I'm going to plug in negative 4. Negative 4 plus 1, which gives me x is negative 3. That ordered pair right there is negative 3, negative 4. Okay? Now, I have to plug in the other y value as well. So let's do that. X is equal to 3 plus 1. Remember, I keep scrolling up and down, sorry. But now I'm plugging in the number 3 for y, okay? Which gives me x is equal to 4. So this ordered pair is 4, comma 3. All right? So you have 2 points of intersection. I'm going to write my final answer as a solution set, okay? I'm going to ask you to do the same thing. So here's my solution set. One point of intersection is negative 3, negative 4. And the other one is 4, 3. Then you're done. So you can definitely see that the visual that I showed you earlier, you're in the case where the circle and the line intersect each other twice. So you have something like this, right? You got a line that's intersecting your circle at 2 different points. Cool? Let's look at another example. Okay, you guys, here's our second system that we want to solve. Now, the first equation is the equation, since x and y are being squared, your options are circle, ellipse, or hyperbola. I did not say parabola because when you have a parabola, only one variable is being squared. Now, I know it's not a hyperbola because this would have to be a minus sign. Matter of fact, I have a minus sign on the bottom one, and both variables are being squared. This is the equation for a hyperbola. What is this? Since it's a plus sign, your options are circle or ellipse. But if this was going to be a circle, both coefficients of x squared and y squared would have to be the same. But they're not. One is 1 and the other one's 4. So this is an ellipse. So you and I are trying to figure out, when does this ellipse intersect with the hyperbola? Or does it at all? So we'll figure that out now. I'm going to use the elimination method here. I notice that all the variables are being squared. So what I'm going to do, and remember there's many options for this. What I'm going to do is I'm going to multiply the first equation by negative 2. All right? When I multiply the first equation by negative 2, I end up with negative 2x squared negative 8y squared is equal to negative 50. And now I can see when I add my equations that the x terms are gone, and I'm left with negative 11y squared is equal to negative 44. I suggest we divide both sides by negative 11, which will lead us to y squared is equal to positive 4. Now, when you take the square root of both sides, you have to remember the plus or minus symbol, okay? And the square root of 4 is 2. You have 2 different y values that you need to plug in. I suggest you plug in each of these y values into one of these equations. I'm going to go for the first equation, okay? I'm going to plug them in here. X squared plus 4y squared is 25. Now, when I plug in positive 2, I get the following. X squared plus, remember that 2 squared is 4, so you got 4 times 4, which is 16, is 25. All right, so subtract 16 from both sides, and 25 minus 16 is 9. Take the square root of both sides, and you get plus or minus the square root of 9 is 3. I want you to keep track and not lose sight of what we've just discovered. When we plugged in the number 2, positive 2, we got 2 different x values. We got positive 3 and negative 3. All right? That's just from plugging in positive 2. But we have to plug in negative 2 as well. So let's do that. You're going to find that you get the same thing, because even when you plug in negative 2, when you square it, it's still going to be positive 4. But I'll go ahead and show my work. All right. The equation that we're plugging into is, do you remember, it's x squared plus 4y squared is 25, right? Now, we already plugged in 2, so now we're going to plug in negative 2. Now, I feel like this is redundant because you and I know that when you square a real number, whether it's negative or positive, it becomes positive, right? So notice that we're getting the same thing as before. So we're getting x squared is equal to 9, right? X is equal to plus or minus 3. Now, so that all of that was the same. The only thing that's different is that you and I plugged in, let me see if I could separate this really quickly. There, okay. You and I plugged in this time around negative 2, didn't we? All right. And when we plugged in negative 2, one x value was 3, the other one was negative 3. So we're done. Notice that you have these two solutions, and you also have, let's see if I can continue scrolling here. You also have, there. You also have these two that we found earlier. You remember? So basically you have 4 points of intersection. You got positive 3, 2, positive 3, negative 2, and then negative 3, 2, and negative 3, negative 2. Let's write all 4 solutions in set notation. So here's my set. You got 3, 2, 3, negative 2, you got negative 3, 2, and you have negative 3, negative 2. 4 points at which the hyperbola and the ellipse intersect. All right, you guys, here's our brand new system. I would love for you to pause the video and try to identify which kind of conics we have. All right, I hope you did that. This here, because both variables are being squared, it's not a parabola. Because this is a plus sign, it's not a hyperbola. So then this is either a circle or an ellipse. Because the coefficient of x squared is 1, the coefficient of y squared is also 1. Because the coefficients are the same, I know this is a circle. Down here, only one variable is being squared, which is x. This is a parabola. A parabola opening upward because x is being squared and its coefficient is positive. All right, we have a circle and a parabola. Okay, now, what I would suggest that we do here is use substitution. You see that y is already solved for in equation number 2. This is equation 2. This is equation 1. In equation number 2, y is already solved for. That's really convenient. I'm probably going to come back here later on. Now what I want you to do is consider going to equation number 1, which says x squared plus y squared is 16. And make your substitution for y. So y is x squared minus 4. Don't forget, you have to square it, right? It's y squared. All right, cool. Now, if I can come over here, way up here on the right part of the screen, you should be getting x squared plus, now remember you have to expand this correctly, so when you do, that means you have to write this as x squared minus 4 times x squared minus 4, and then FOIL, you're going to get x to the 4th power plus, or not plus, the next sign will be minus, because this is minus here, minus 8x squared plus 16 is equal to 16, okay? Equal to 16. Cool. Let's combine like terms. So on the left you have x to the 4th, and then x squared minus 8x squared gives you negative 7x squared. And then you can, watch this, this 16 and this 16 cancel. And so now your equation is set equal to 0. Cool? Factor out an x squared, leaving you with x squared minus 7 is equal to 0. Set each factor equal to 0 and solve. So when you take the square root of both sides here, you just get x equal to 0. Here you're going to have to add 7 to the right and then take the square root of both sides, which gives you plus or minus root 7. All right? Okay, guys, please notice that you have 3 different x values that you're going to have to plug in. 3 different x values, okay? So let's see. Let me scoot up here. Well, first, before I change the screen, we're plugging in each one of these x values, all 3 different ones, in this. Y is equal to x squared minus 4. All right. This was equation number 2. Equation number 2 says y is equal to x squared minus 4. You're going to see me plug into this equation each of our x values that we just found. All right, here we go. Plugging in x equal to 0 gives you negative 4. So what we just figured out is, maybe what I can do is over here. When you plugged in 0 for x, you got negative 4 for y. All right, let's go for the next one. This time, let's plug in root 7. Root 7. Don't forget you have to square it, because that's what the equation says to do. So then root 7 squared is just 7 minus 4, which is 3. So now we plugged in positive root 7, and we got positive 3. Just kind of keeping track here. All right, one more x value to plug in, negative root 7. You're going to get the same thing because of my same argument that I was making earlier. When you square a real number, you always get something positive. So this is 7 again, and 3 again. The only thing different is what you plugged in. Negative root 7, positive 3. So then your final solution set will be 3 solutions. You can combine these two, and you can say plus or minus root 7, comma 3, and 0, negative 4. Please notice, although I use shorthand notation, you have 3 points of intersection. You have 3 solutions. All right? Cool deal. Okay, guys, this wraps up our lesson. But before I let you go, I just want to call out 2 things. When you are solving a system, just like in earlier studies, so what I'm about to tell you next, you should recall from earlier studies. If your variables cancel out and it leaves you with a contradiction, something like, I'll make something up, okay? If your variables cancel out in the process and you're left with a contradiction, like 0 is equal to 5, or 0 is equal to 3, or 7 is equal to 9, or something weird like that, a contradiction, it doesn't make sense, then your final answer is no solution, okay? Which just means that those conics that you're looking at, they just don't cross. They don't ever meet, okay? Another thing, if you are solving your system and you get imaginary solutions, Remember that we are in the real number plane, the Cartesian plane. And so we only have real numbers to work with when we're graphing these conic sections. So if ever you get imaginary solutions, that means there is no real number solution, okay? Now, I have to be careful about this, okay? If you get imaginary solutions, if all of your proposed solutions are imaginary, then indeed it's no solution. Now listen to me carefully. If you have 3 proposed solutions, 2 of them of which are imaginary, then the imaginary ones you toss in the garbage, but you keep the real numbered ones. Does that make sense, everybody? Whichever proposed solutions are imaginary, you can ditch them. They're extraneous. Those aren't not going to work. But if you have proposed solutions that are real numbers, that means no I, then that means you keep those ones, okay? All right, you guys. Good luck on this section. I'll catch you later. This completes chapter 6 for us. Good job. We made it.